Meet Jordan, Priya, and Marcus. They are three cyclists lining up at the track, revving up for a race. Our goal is to figure out who is going to win this race before they even cross the finish line. But there is a catch. Each racer is tracking their speed using a completely different mathematical format. Jordan's speed is tracked as a pure mathematical equation, y equals 0.25x. Priya's data is dropping into rows and columns on a table, tracking her distance over time. And Marcus's speed is plotted out as a single angled line on a coordinate graph. To find out who is actually the fastest, we have to look past the packaging. We need to unwrap all three of these formats and translate them into one shared comparable number, the unit rate. We will start with Jordan's equation. This is the easiest format to read because the unit rate is sitting right there. It is simply the coefficient, or the number attached to the x. That gives Jordan a unit rate of 0.25 miles per minute. No extra math required. Moving over to Priya's table, we do a little calculation. We divide her distance, the y value, by her time, the x value. Calculating 1.5 divided by 5, or 3 divided by 10, every row gives the same number, a constant unit rate of 0.3. Finally, we look at Marcus's graph. To extract his rate, we calculate the rise over the run starting right from the origin point. His line goes up 6 miles on the y-axis and over 30 minutes on the x-axis. We divide that rise of 6 by the run of 30, and we get Marcus's unit rate, 0.2 miles per minute. Now that we have stripped away the formatting, we are left with three plain numbers. Comparing 0.3 to 0.25 to 0.2 is incredibly easy. But before you line up your own numbers to declare a winner, you need to check for two common mathematical traps. Trap number 1 is mismatched units. You might see a rate of 0.5 compared to a rate of 60 and assume the 60 is faster. But what if the 0.5 is miles per minute and the 60 is miles per hour? This graphic shows why we have to convert our units first. If we multiply 0.5 miles per minute by 60 minutes in an hour, we get 30 miles per hour. Now we can safely compare 30 against 60. Trap number 2 is relying on raw y values. If you look at two lines on a graph, it is tempting to glance at the highest y value and assume that line is the fastest. Here, A's y value of 28 looks higher than A's 18. But because x values differ, we divide y by x. 18 divided by 3 gives A a rate of 6. 28 divided by 4 gives B a rate of 7. Line B genuinely is faster, but we only know that because we did the math. Never trust a raw y value or a mismatched unit. Always calculate the true unit rate. Let's bring that logic right back to our race. We have our three extracted unit rates, and now we are going to drop all of them onto one master graph. This chart shows the race in a single image. From 0, 0, Priya's 0.3 creates the steepest line, putting her in the lead. Jordan's 0.25 is in the middle, and Marcus's 0.2 forms the shallowest slope. When you map proportional relationships together like this, the visual geometry perfectly matches the math. The biggest unit rate always produces the steepest line. So what does this look like in reality? If our track is exactly 12 miles long, we can find Priya's finish time by dividing that 12 miles by her unit rate of 0.3. She finishes the race in 40 minutes. Jordan divides his 12 miles by 0.25, finishing in 48 minutes. Marcus divides his by 0.2, crossing the line in 60 minutes. Priya's fractional advantage in unit rate means she wins by 8 to 20 full minutes. Now it is your turn to test this out. Here are 4 quick scenarios where you have to compare relationships across different formats. Take a second to find the winner for each. Let's check the results. Store A is cheaper at 0.75 per pound compared to Store B's 0.9. Car A is faster because Car B's rate converts to only 40 miles per hour. Relationship B has a higher rate of 9, and Hose 2 fills the pool faster with a rate of 2.8. Every time you need to compare proportional relationships, the strategy is the same. Unwrap the format, calculate the unit rate, match your units perfectly, and let the plain numbers do the talking.